I shall call him Mini.
There it is. We're going to prove triangles similar. Start off with a little tribute to Austin Powers, Dr. Evil, and Mini-Me. Yes, triangles similar. Same shape, different size. One's going to be bigger than the other. We did this in the last unit, but this time our focus will be on triangles and doing some proofs. What? We gonna do some proofs? Yes, maybe like 2-column ones? Ooh, I don't know. We'll see what happens. Okay, so are these triangles similar? Well, do they look similar? Yeah, one looks bigger than the other, but we got to be more technical, more precise. We need to use some information. So let's see what's given. We're given that angle C is congruent to angle D, and also down angle A is congruent to angle O. Well, is that enough? We have two angles. We got an angle and an angle. Let's see what else we can think about here. How about the other angle? Well, let's see. Of course, we saw this before. If we're just making up some numbers here, but if angle A was, say, 100 degrees, and angle C up here is, oh gosh, it's little. Let's call it 10 degrees. Maybe not that little. Then it's got some matches over here, 10 degrees, and then that 100-degree angle. We'll do the math. If you take 180 as a total, what's that last angle going to be? Man, I can't do the math. Yeah, okay, 70 degrees for angle T. Angle G is no different. Same total, same 180, same 70 degrees. So we have the third angle, 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 angle. We saw back in chapter 4 when we did triangle congruence that three angles the same, not congruent, but what were they? Similar. So that's our first shortcut. We're just going to prove the three angles are similar. Let's formalize that. Here we have our angle-angle similarity, and you notice you're going to abbreviate that AA with the similarity sign. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Oh my gosh, hope your handwriting's better than mine. Triangles are similar. All right, so let's mark this up. So we have C congruent to D, A congruent to O. These are similar triangles. How would we write that, though? The order still is important. We're still going to match up parts. So if I go C-A-T, like, oh, cat, sure enough, spells the word. Okay, C-A-T is similar to, same order, same matchups, D-O-G, triangle cat, similar to triangle dog. Now, they won't always spell a word for you. I'm just trying to be funny here. But notice the similarity sign, not congruent, similar. There's other shortcuts. Side, angle, side. Just like side, angle, side congruence, there's one for similarity. Let's read through it. If an angle in one triangle is congruent to an angle in another triangle, and the sides that include the angles are proportional. Not congruent, proportional. Remember, they have to include the angles, just like we did this before. Then the triangles are similar. The triangles are similar. You guys really ought to try to write with a mouse sometimes. Not so easy. We're going to mark this in our picture. So here in our picture, let's read through our givens. Angle O is congruent to angle A. And then, oh, what's this? BO, that's this side, is in a ratio with MA, and it's going to equal another side. Well, which other side is it going to be in proportion to? For side angle side similarity, we need the included angle. So we need this angle to be between the other side that we pick with the original. That's going to be these two right here. So B is to O. Sorry. So BO matches up MA in a proportion with OT, there in green, and AN. As long as those are good, we have similar triangles. So we would write our triangle similarity statement this way. Let's go BOY, triangle boy, is similar. Same matchup, same order, MAN, triangle MAN. Boy is similar to man. Awesome. All right, there's another shortcut. That's just number 2. Last shortcut for similarity is called the side-side-side similarity. You might be able to understand what this means with just a quick read through. If all 3 pairs of corresponding sides in a triangle, in 2 triangles, are proportional, then fill it in one more time. The triangles are similar. Let's see, is my handwriting getting any better? Let's check that back to the original. Oh yeah, I'm getting better. Awesome. Okay, so how does that go? This time we're not looking at angles at all. We're just looking at comparing all the sides up. So CO goes with PI. That one started for us. What would CW go with? Well, pretty easy if it's not turned around. That'd be PE. So CW over PE in a ratio. And that needs to match up lastly with the ratio of OW to EI. And I want you to notice that I'm being really consistent about my order here, i.e., whoops, I just lied. I'm being consistent about my order here, and then I mess it up. Okay, OW would be to IE. Oh, shoot, I had it right. To IE. All right, so if those are all true, if that's all a true proportion, then these triangles would be similar. How would we say this? Let's go COW. COW would be similar to triangle PIE. Nothing better than a good old cow pie. So how does this work in actual problems? Let's take a look at some examples. Decide whether these triangles are similar. If they are, we're going to write a similarity statement. Okay, I'm looking for a shortcut. Now we're pretty used to this. We see these vertical angles. I like that. That's usually helpful information. Vertical angles there. Now I've got some sides given. Let's see what we can say about these sides. We'll just match them up. Take 18 here in this bottom triangle. And since that's the longest of the two sides down there, let's match it up to, which one would it go with? Oh, well, 60 is longer than 50, so it's going to match up with that one. I'm going to go 18 compared to 60. And let's see if that's equal to my other side. So that's going to be 15 compared to 50, going short to long. 15 compared to 50. So let's pull up the calculator and just see if that's a true proportion. If we divide those out, 18 divided by 60, let's see what we get. 0.3. Okay, how about 15 divided by 50? We want to see if this is a match. 0.3 also. Okay, let's drag that over, because that's our proof. That's going to be our proof that these are in proportion. And so these are similar triangles by side angle side. Let's get the list here. So triangle WNM, that goes from W here in the middle down to N along the red side. So we're going to go W to U, triangle WU, the red side, and then finish it off at V, matching those up. And this is by, for a reason, we'll put side angle side similarity. Remember your little symbol there. Okay. How about on this one? Let's see what we've got. No angles, just a bunch of sides given. You might be able to guess this. We're going to try checking out all the sides, see if we have a side, side, side shortcut. So let's be careful about this. Where's our shortest side, that 8 there? And where's the shortest side here? That's the 48. Oh, this looks like it's nice and in order for us. Okay, so I'm going to take 8 over 48. Those are the shortest sides. Now, how about the middle side? That looks like it's 9 and 56. There's my next fraction, 9 over 56. And then we'll finish that off with our longest sides, 10 and 60. And now we just got to check out, see if these are all in proportion. Let me clear this. Okay, just divide them out. So 8 divided by 48. Bam. And then 9 divided by 56. Oh, wow, they're real close there. Check it out. That's not too far off, but it kind of loses it there in the last part. So these are not in proportion. I don't have to check out the last one. I could, I guess, if I want to, but right there that tells me they are not in proportion. These are not equal. I'm going to bring this in. I'm just going to resize this, include it in my work there, and so now we know that these are not equal. And that triangle is not similar to anything, not similar. Awesome. Okay, here's our next example. These triangles, I hope you see two triangles there. There's this little triangle kind of embedded inside of this big triangle. I'm seeing a couple ways we might be able to do this. I've got all the sides, or at least enough information to figure them out, so maybe we could do a side-side-side test. But I notice right here that angle Q, check it out. Is that angle an angle of the big triangle? Yeah. But it's also an angle of the little triangle, DCQ. So they share this angle, angle Q here, so I'm going to use that angle, and then I'll come out from there in my short triangle and my long triangle. So I'm going to come out from angle Q along the 24 side, compare that to angle Q on the big triangle out to R, that's 78. And then let's go the other way from angle Q down along this side, just on the short triangle, the small triangle, 36. And then what is that all the way? We'll just have to add this up. So 36 plus 81. That's 117, I think. So 36 divided by 81 is 117. How does that look if we convert those on the calculator? So let's say 24 divided by 78. Oh, try to match that up. Let's see what 36 over 117 is going to do. I'm a little nervous here. I'll be amazed if this works. Oh, I am amazed. All the way down, those are in proportion. Kind of cool. So we have two pair of sides in proportion. We have the angle that's between them congruent. This is a similar triangle. We've got triangle QDC, so QD goes to QR. That's the first two. And then the last one we'll just throw in the S there. And that shortcut was our side, angle, side. Now, we could have done this with side, side, side. You could check it out using these two longer, the last two sides here. And probably going to work too. 32 over 104. I'll bet you anything that that's equal to that same ugly decimal. Why don't you try it out? I'm just going to write it down because I'm convinced by the other proof. All right, now in this final example, we're asked to find some missing parts. And we did this in the last video. This time, how do we know we can even set up those ratios? Only if these are similar triangles. So first I've got to show that they are similar. That's a question. And always check this. Don't just assume they're similar, because if they're not, all your calculations are going to be for nothing. All right, well, notice there's parallel lines. I remember parallel lines tell me angles have some matches, and I see this angle D, this angle over here at E. Those are going to be congruent. If you remember, those are corresponding angles, so they're definitely congruent. If I come up to this one at C, this angle here, where's its match? By that same reason, these corresponding angles are congruent, so there's another pair. These are similar because I just found two angles the same in both. Of course, angle A down here shares angle A. It's congruent. So these are similar by angle, 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 or, you know, we can just use angle, angle similarity. Might as well just save some ink. So they're similar. That means we can set up proportions to find the missing parts. Let's take a look at this. What does this 3 go with? 3 goes in the little triangle, goes to this 5 in the big triangle. And let's see, how about we get the side Y first? So let's take side Y, and side Y is going to be matched up to this whole length across, which is how long? It's got a Y piece and a 3 piece combined together, so that's going to be Y plus 3 total. Y plus 3, and in our cross multiply we can go ahead and take 5 times Y. Be sure 3 is multiplied by Y and the plus 3 both together, so you're going to distribute that. Let's write it like this to start out. Okay, so bring the 3 through the parentheses. So we've got 3Y, 3 times 3 is 9, 3Y plus 9 is 5Y. Subtract that 3Y over, you're going to get 2Y is 9, and Y, if we divide both sides by 2, Y is 4.5. There we go. Okay, we're not done. We've got to get X here too. So let's see. Let's use that same 3 over 5. The little triangle has a 3 and it corresponds to the 5 in the big triangle. So 3 over 5. And on our X, that's this side here, X in the little triangle, where's its match? Big triangle's got 3.5 as its match. This one doesn't look so bad. X times the 5 is 5X, of course. And 3 times the 3.5, let's see, 3 times 3 is 9. I think that's 10.5. You'll have to check me. Tell me in class if I'm wrong on that. Divide both sides by 5, and X alone would be 2.1. Sure hope that's right, because I know I'll hear it if it's not. Okay, they're similar triangles. You got 3 shortcuts, ways to prove they're similar. And then, of course, you can set up proportions to solve for any missing parts you've got. Your turn to do some try these.